Like Roland said, I've been working in the paper machine clothing business for about 23 years. I've been a field service engineer, I've been an application engineer, and the last number of years I've been developing test equipment for paper machine clothing, especially handheld tools to optimize the performance of the felts. This presentation will be about the permeability of press felts, and in my opinion, press felts are the most complicated piece of paper machine clothing. The application engineer has a theoretical over 100 million theoretical options to choose from. Also, manufacturing of press felts is not very easy, especially the reproducibility can be quite a challenge. But luckily, measuring and judging the permeability is not that difficult. Felt permeability or problems with felt permeability can have, well, many phases. For example, if you have a poor dry content on the sheet, the felt can be too open because of wetting, but it can also be too dense because the felt cannot release the water at the Uhle box. You can have sheet crushing. Of course, the felt is too dense. Or you can have the non-plus ultra version of sheet crushing. I would call it felt crushing. Poor pickup can be related to the permeability of the felt, can have many other reasons as well, but felt permeability is just one of them. And just one other example is shadow marking, usually related to a too open felt with too high flows in the nib, especially in combination with a suction press roll. So basically, felt permeability can cause a lot of headaches. I forgot one. The blowing in before the fourth press. So even further up in the press, the permeability can play a role and can cause some headaches. So what can we do against those headaches? Well, we could look at the data sheets that come with the product. I mean, on every data sheet, we see permeability values. So let's take a look at how the manufacturers obtain these values. For that, they use a tester that more or less looks like this. You have a fabric sample that is placed into the instrument. Then a little bit of air is applied to the fabric, just enough to get a very small pressure difference on the pressure gauge. And with a small pressure difference, I mean about 2 millibars or 0.03 psi. And once that pressure difference is there, you just simply read the flow meter and you have your permeability value. And well, that works okay for plain fabrics. However, for press felts, we have a batt. With the measurement that we just shown, or is still shown on this sheet as well, the finest layer will determine the total value of the total permeability value. So in the case of a felt, it's this top layer. It's roughly 10% or less of the total weight of a felt, but it fully determines the permeability value on the data sheet. The other 90% is not relevant for this measurement. However, in the machine, conditions are quite a bit different. Most important thing is that the press felt is compressed in mid-nib. The structure of the felt is totally different. In mid-nib, we move water, not air. We move huge amounts of water. And then the pressure inside the nib is also about 1,000 or more times higher than the 2 millibars that we use in the lab equipment. So really, the permeability value on the data sheet is very good for quality assurance for the manufacturer. but it has no real use for the papermaker. So let's see how the felt permeability is affecting the dewatering. And for that we have to distinguish the two types of nip dewatering, or dewatering we have, Uhle box dewatering and a nip dewatering. Because these two types of dewatering have different demands on the felt permeability. When we start with the Uhle box dewatering, we have a schematic here with two press rolls, a felt, and a sheet on top. At nip entry, we want the felt to be open. We want the water to easily transfer from the sheet into the felt. At the nip exit, of course, we don't want that to happen. We want the water to stay inside the felt, so the top layer of the felt should be dense. And then move on a little bit to the Uhle box. Over there, we want the water to get out of the felt again, so we want it to be open again. So if you look at the demands on the felt in running direction, it needs to be open, it needs to be dense, it needs to be open. That's a bit difficult to achieve with only one felt. For nip dewatering, the situation is slightly easier, because for nip dewatering you require higher hydraulic pressure in the nip. For that, you feed more water into the nip compared to Uhle box dewatering machines. The water comes from the sheet, of course, but also the felt carries more water into the nip. And once you are entering the nip, you still want to build this pressure, and once you have it, the good thing is the water can move in only, or needs to move in only one direction, from paper side to roll side. So at the nip entrance, you still want the felt to be open, but it doesn't have to be that open as in the Uhle box, because you want to build up this hydraulic pressure. At the nip exit, again, you want it to be dense, no re-wetting. And at the Uhle box, well, the Uhle box is not so relevant anymore for a nip dewatering machine. It can take away a little bit of water, but you don't want it to take away too much, because you need to carry it back into the nip again. So it's quite okay if the felt is relatively dense. So if you look at the sequence again in running direction, you want it to be not too open, you want it to be dense, and again not too open. It makes it a little bit easier for the application engineer to develop a good press felt for nip dewatering. But the right felt permeability is always difficult, because you still want it to be open sometime, you want it to be dense the other time. So the result is always a compromise. Now let's get a little bit more practical on how can we measure the felt permeability on the fly. For that you have the water flow systems that more or less try to simulate the situation in the mid-nip. You inject water, pressurized water, and you measure the flow as a function of that water, as a function of the water pressure. Although this is a very good representation of the permeability profile of the felt, it are also relatively costly instruments, and not many mills have their own set of equipment. So a more common type of measurement is are the airflow systems, and they measure the airflow or the air velocity through the felt into the Uhle box. As mentioned, it's an air permeability test. It's not a water test. But although the water permeability is very important in mid-nip, you also have to have some air permeability for all the suction supported rolls, like the pickup roll and the suction press roll or transfer rolls. You measure this air velocity usually with one of two probes. it can be either a small vane or a hot wire. And the hot wires are cheaper, but due to the corrosive environment, they usually don't last very long. So evaluating this measurement could be quite simple. The higher the air velocity, the more open the felt. But of course, the vacuum plays a role as well. The higher the vacuum, also the higher the air velocity. So to judge the felt, you have to keep two numbers in mind, the vacuum and the air velocity. Well, two numbers are always a bit more complicated than judging one number. So I try to make a dynamic permeability indicator. And to explain that, we'll have just three situations where you measure a flow of 4 meters per second at 20 kilopascals of vacuum, or 4 meters per second at 30, or 4 meters at 40. It's obvious that although the measured air velocity is the same in three situations, the felt permeability is not the same. So what I've done is convert the air velocity to a standard vacuum of 10 kilopascals. And then you'll get these these numbers, and you'll just have one simple number telling you a little bit more about the felt permeability. So after doing this for a while, at some moment in time, you'll probably have to conclude that a felt is dense. The next big question is it compaction or is it contamination? And in order to answer that question, you need to take the felt caliper into account as well. Because then we can make a very nice matrix. We can put the felt of the dynamic permeability indicator on the horizontal axis. We can put the thickness or caliper of the felt from relatively thick to relatively thin on the vertical axis, and then we have nice 4 quadrants. If the felt is thick and dense, it is most likely contaminated. So you see that by reduced speed or sheet crushing, for example. If the felt is open and thick, it's still in its break-in period. Again, poor dry content and reduced speed. If the felt is open and thin, it's worn. You'll see some base marking in your sheet. And if the felt is dense and thin, it is probably compacted or over-compacted. Now that we've determined the condition of the felt, is there something that we can do about it? And unfortunately there, the possibilities are limited. If we use the same metrics, if the felt is contaminated, of course it's obvious you can wash the felt, and usually that can be quite effective for a while. If the felt is too new or too bulky, there is one thing you can do, both for nip dewatering machines and Uhle box dewatering machines, and that is add a little bit more water to the nip, have this higher hydraulic pressure that you need for nip dewatering, but it will also help to compact the felt and reduce the break-in time. But if the felt is worn, there's only one solution, just like when the felt is over-compacted, it needs to be replaced. And that brings me to the end of my presentation and 4 conclusions. Conclusion number 1 is permeability is always a compromise. A perfect permeability does not exist. The second conclusion is that the permeability value on the data sheet is not relevant for paper makers. You don't have to look at it. It doesn't help you to compare felts. It doesn't help to decide on felt designs. It's, for us, useless. Nip dewatering requires more denser felts. And the last conclusion is that if you really want to monitor the air permeability over time, you should regularly measure the air velocity, the vacuum, and the caliper. And please react in time, because your options are limited. That's it. Any questions?
So the floor is open to any questions from Marcel. Well, I might have one, Marcel, of all the different instruments that you were describing, which do you feel might have the best payback to the mill if they were to start investing in something to measure online?
Well, if you look at the cost price of our instruments, if you can prevent one break, you've earned back a set of three instruments in one break in 20 minutes. It's just a matter of, well, you have an instrument, but you also need to work with the data. You need to understand what you're measuring and respond to that. So that is a bit of knowledge that is required, and that's one of the reasons why I'm here.
Any other questions? Well, once again, I'd like to thank Marcel.
All right, thank you very much.